Hello students. Today we are going to see this topic memory representation of fundamental data types. So what is mean by this fundamental data types? We have seen in the last class itself the fundamental data types are character, integer, float, double, etc. Okay. So here you can see that there is a table. So in that data types are given as four rows. Okay. Character, integer, float, and double are the basic characters, basic data types. Okay, so this basic data types. Okay, how this basic data types are represented in the memory. Okay, so why we have to represent this memory uh, memory of database. Okay, so data types. So you can see that our program is compiled before it is executed. Okay. So for execution, you need a precise memory location. Okay. So if you are using a common or a data type with a data representation or memory representation without these data types, then the compiler will be confused to use the uh, data which are handled by the program. Okay, so to regulate or to give a standard way of using the memory location, they are using this uh, data types. Okay, so to help the compiler to organize all the datas in a particular way or the standardized way is known as memory representation of fundamental data types. Okay, so one of the most important reason for declaring variable as per data types is to allocate appropriate memory or space in the memory. Okay, so the main aim of declaring a variable is to know the memory, allocate some memory space for that particular data. Okay, so that is why we are declaring the variables before using the variable. Okay, so here you can see that how much memory space has been allocated to each data type. Okay, so here you can see that character, a single character variable will be allocated 1 byte, integer 2 byte, float 4 bytes, and double 8 bytes. So in terms of bits, here you can see that in the next uh, column and the range value. Okay, so just to know the bytes or bits. Okay, anything is necessary. So the data types and their responsible memory space. Okay, so respective memory space that are allocated to this data type. Okay, either in bytes or in bits. Okay, so it may be asked as a one mark. Choose the best answer uh, in your exam. Okay, so nothing more than that can be asked here. So next is here you can see the data type modifier. Okay, so here you can see that uh, modifiers are used to modify the storage capacity of the fundamental data types except void type. Okay, so this modifiers can be used. Okay, so this modifiers is nothing but a word. Okay, a word or a keyword that can be used before or after this data types, fundamental data types like character, integer, float, and double. So before that they'll be using a words like some flow, signed, unsigned. So here you can see that these are all the four words. Okay, so signed, unsigned, long, and short. So this provides this this four words or four keywords can be used before the fundamental data types to modify them. Okay, so say for example the integer, it can hold only 2 bytes of data, but in real world uh, you are storing data apart from or 2 bytes, okay, which is larger than 2 bytes. So you have to store it as an integer data only, okay. So if you want to extend some of the data in the same integer data type, then you can use any one of these long a long int, uh, which can store about extra some bytes to store the values, okay. So if you are using a very short number of integer, then you can use this short int, so which provides very less data, okay. So we are all going to see this as a tabular format, so we just make a note of it. As an exam point of view, this this topic is uh, uh, very very less important compared to other things, okay. So you just read it to know it, okay. So when you as a career based topic, so you have to know it, okay. So when you go to a software programming field, then you must know all these things, okay. So so first of all, this is a very important one as a career based one, but as an exam point of view, it is not necessary, okay. So please read it, okay. So here you can see that modifiers are used to modify the storage capacity of the fundamental data types except void type, okay. So void type does not comes in does not cannot be used any modifier with it, okay. So here you can see that usually every fundamental data types has a fixed range of values to store uh, data items in the memory. For example, integer data types can store only 2 bytes of data. In reality, some integer data may have more length and may need more space in memory. In this situation, we should modify the memory space to accommodate the large integer values. Modifiers can be used to modify, expand or reduce the memory location of any fundamental data types. These are also called qualifiers. Okay, so you can see that this is an important two mark. What is meant by qualifier? Okay, so this qualifier is also known as modifiers. This modifier expand, increase or decrease, reduce the memory space according to the needs. Okay, according to the fundamental data types, okay. So this is an important one. So you have to know the what are the four modifiers: signed, unsigned, long and short. So here they will be given some tables, okay. So you can use combinations of the modifiers, okay, like signed and unsigned. In a, here they are given us, okay, short, unsigned short, signed short, int, unsigned int, signed int, long, unsigned long, and signed long, okay. So these are all the different modifiers that can be used, mm, in the fundamental data types to expand or reduce the memory location according to your needs, okay. So this kind of table will be available for all the four data types: integer, character, float and double, okay. So and the last table will be shown to you about the different different compilers, okay. So different types of compilers are available. So these compilers will be allocating different memory space for different data types. So you have to know all these things, okay. So just make a note of it. So as an exam point of view, you'll be it will be given very less importance. And if it is very important if you are going to this software coding field, okay. So please make a note of it. So next is you can see that there will be a small program to show all this examples. Okay, so size of is a function. Okay, it is a predefined function uh, that will tell you how much memory space is being used for the particular variable. Okay, so here you can see that they have declared all the different size of different uh, the different modifiers and the uh, and their particular data types. Okay, so short A, unsigned short B, signed short C, int V, int D, unsigned int E, signed int F, long F, long G, unsigned long H, signed long I, character J, unsigned character K, signed character L, float M, double N, long double P. Okay, so these are all the different data types. So by using the size of A, B, C, D, you can find out what are all the different types of given in bytes here. Okay, so this particular compiler provides these kinds of uh, memory allocated to different types of datas that are present here. Okay, so you can just find the result here. So you can use number of suffixes, okay, to store um, suffixes in the value itself to store the values in this data type. Okay, so L and U. Okay, large means L, and U can be unsigned U. Okay, so this kind of suffixes can be added to the numbers to store that in the um, store it in the particular data type. Okay, so next is variables. So what is variable? Variable is a is a memory location that is um, allocated to the particular data type. Okay, say for example int a, so 2 bytes of memory location will be allocated to this variable name a. Okay, so you can't able to memorize the memory location like or memory and a name. It will be like some numbers, so you cannot able to memorize it. So you can provide a name for it. Okay, so a b c, so it should be easy to remember. So that's why it is called as variable declaration. Okay, so it's known as variable. So we'll see variables are user defined names assigned to specific memory location in which values are stored. Okay, so it is a user defined name that is provided to this memory location to store some value. Okay, so there are two different types in memory location, so that values. So R value is the value which is stored inside the memory location, and L value is the memory address. Okay, so you can see that R value is the value that is stored inside this memory location. In the diagram 9.114, you can see that 65 and 100 are the R values, and the respective 0x130E are the address value, which is known as L value. Okay, so next of you can see that a declaration of variables. So a declaration of variables is very important. If you are not declaring a variable, then you will be given an error message while using this variable. Okay, so first of all we'll see the syntax for variable declaration. So syntax is data type and the number of variables you need. Okay, you can declare a single variable, or even you can declare multiple variables at the same time in the same instruction. So data type variable 1 comma variable 2 variable 3, so up to n number of variables can be added, and at the end of the variables you have to give the semicolon to indicate the end of declaration. So here they have given some example. So integer data type provides 2 bytes of memory to its each variable. Okay, so number one will have 2 bytes, number two will have 2 bytes, number sorry some will have 2 bytes. Okay, so this is a way that uh, how these variables are declared. So how the compiler allocates bytes for this memory location. So here it is given as uh, in the picture you can clearly see that how many bytes of memory location will be allocated to each memory. Okay, each variable. So next is you can see a different word which is known as junk or garbage collection. So after completion of this program, that memory will be reallocated to work with the next program. So that is known as garbage collection or junk. Okay. So this is a feature that will be available in all kinds of object-oriented programming language. So this object-oriented programming languages like C, C++, Java, and Python will have this feature, which will collect the unused memory after the finishing of program. Okay. So here you can see that in this example they have created three variables and use these three variables to print some value. Okay. So with this we'll finish the class today. We'll see the initialization of variables in the next class. Thank you, students.